7 UNC Charlotte engineering students were tasked with creating a proof of concept for a leak detection system for A.O. Smith. Let's meet our industry supporters and mentor.
Hi, my name is Danny Royston. I'm the Director of Operations here at A.O. Smith in McBee, South Carolina. I've been with the company for 23 years. Worked in 4 different locations, 3 different states, and 2 different countries. And everywhere I go within this organization, the people are exceptional. They care about not just about doing a good job and servicing the customers, but also about their neighbors and the people that they work with.
My name is Bandar Hamada. I'm the Manufacturing Engineering Manager here at A.O. Smith McBee. As far as this project goes, 99.9% of the heaters that we build, they don't leak. They go to the customers and they last for an average of 10 years. So this is important to us because this is the last leak check that we do before the tank goes to the customer. So we have a lot of leak check processes throughout the plant, and this is kind of the last one we do. It's kind of pass or fail, just to get yet another layer of safety net on into our process.
Hi, my name is Gilberto Pagan Cabrera. I am a manufacturing engineer level 2 here at A.O. Smith in McBee, South Carolina. My main job consists of helping manufacturing processes around the plant. I help solve issues for operators, make processes more efficient, less taxing on the operators, kind of make them be more productive in the line. I also manage projects, small and big. So the small projects are under 5,000. Bigger projects over 5,000, we call them capital. They consist in 3 categories: cost saving, improvements, and basically expansion and growth. It consists of doing return of investment. You got to do some analysis and stuff like that. So I dedicate a lot of time on doing stuff like that.
Hi, I'm John McAlpine, the project mentor for the AOS Test Senior Design Team. I have a background in motorsports research and development, and high-performance testing has always been an interest of mine.
With years of innovation to its name, A.O. Smith is the largest manufacturer of commercial and residential water heaters in North America, with manufacturing facilities globally. The leak detection system was to address 3 commercial BTH series tanks on A.O. Smith's gas assembly line, Department 51. To understand the project scope, the team traveled to McBee, South Carolina, and studied the gas line. This monitor illustrates the various zones of the gas line and performance metrics. Due to the university lab safety regulations, the team became creative in its testing methods to define a leak. We attached a fitting to a metal pipe and conducted various leak tests using pressurized air and water. This test was conducted at the UNC Charlotte Botanical Gardens. A thermal imaging camera and a heat gun were used on the pipe to conduct the thermal imaging test. For acoustic testing, the team used the Amprobe ULD 300 ultrasonic leak detector to detect air leaks with the pipe. The red LEDs represent sensitivity, and here you can see it changing based on where the leak is coming from on the fitting. The team decided to move forward with an acoustic solution. To implement a pass-fail logic to the detector, the team desoldered the LEDs and multiplexed the signals on a PCB to produce one output. No light indicates no leak, while a light indicates a leak. After designing, and more designing, the team decided on this design for the final prototype. The left image illustrates the bottom and the right illustrates the top. An LED ring will sit on the top of the prototype, covered by a Lexan ring with wires running down to a transducer. Neodymium magnets were placed on the bottom to adhere to the tank. The dimensions of the cup were sized large enough to cover the largest fitting on the tank. Here is an electrical block diagram of the prototype. The team used a 9-volt battery eliminator and a micro USB cable for constant sources of power to the system. This is the entire electrical system together. The LEDs are red indicating a leak and green indicating no leak. Finally, this is our 3D printed prototype using ABS material. A bottom view of our prototype with the transducer attached inside, and a side view with an eye bolt on top to attach wires. The team is working on a virtual implementation to describe what the testing process would have looked like. Here you can see our fixture attached to an I-beam so that the process can move with the tank down the line. To complete this project, the next team will need to complete prototype assembly by combining the electrical and mechanical components, test and verify that the complete prototype works, develop a method to calibrate the prototype before use on the line, and finally, implement the solution on the assembly line such that the efficiency is not affected.
What we look for as far as the skilled engineer goes, we look for people who are leaders, we look for engineers who like to think outside the box, and also we look for engineers who follow up on their task. This is very, very important for us.
You have to listen a lot in order to be able to solve problems with other people and build rapport. And it consists a lot of respect. Respecting your colleagues is key in working together with them. Respecting opinions, letting other people speak their mind and not being critical about it. There's different ways of criticizing an idea, and you really have to work on being very objective and very positive and being frank but not be offensive while doing it. We're all one team as A.O. Smith family, and we do want to make sure that everybody in our team is heard and that we take into effect what they're saying, right? Take it seriously.
For new senior design teams, I would advise them to not be afraid to fail. Do not let perfection be the enemy of success. Give yourself enough time to learn from your failures and iterate towards a better result.
So the advice that I would give would be never be complacent. Always challenge yourself to do better. Challenge the employers that you're working with to do better. Be better stewards of the environment, of the resources we have available. You can make a difference, and you will make a difference. And that's my advice. Thank you.